Alright, here's number 7 and 8 from your algebra exam. This function f of x is translated to g of x, which is exactly 2 units to the right and 1 unit down. So g of x is equal to f of x that's been shifted to the right 1 and down 1. So I'm going to just simply take the x's out here and plug in x minus 1, and then I'll just subtract 1 from the end here. So this is 2x minus 1 cubed minus 3x minus 1 squared plus x plus 1 minus 1. So these will go away. So then that's 2x cubed plus 3. Let's see here. 3, no, I think that's a minus. Minus 3x squared plus 3x plus 1. A little binomial expansion in my head. I think that's right. Minus 3x squared minus 2x plus 1. Actually, later consideration tells me that this is a minus 1. Because it would be minus 1 cubed. Okay, and then plus x. Hopefully that's right. So then we have 2x cubed. And then maybe we can try and put these all together at the same time. That's minus 6x squared minus 3x squared. That's minus 9x squared. And this is 6x, and that's 6x, so that's 12x plus 12x. And then the last one is minus 2, and then this is minus, we have a, let's see, we have an x, oops, I forgot to put an x minus 1 right here. That will definitely go to 0, we can get rid of that, but this is an x minus 1. X minus 1. So that 12x will become a 13x. And then that last piece, minus 2, minus 3 is minus 5, minus 1 is minus 6. I hope that's right. Yeah, that's in the right form. Okay, so the next problem says take f of x and g of x, find the set of values that f is less than or equal to g. So I do this probably different than some teachers. I like to make a number line, so I can't put in negative 1. It tells me I can't, but if I put in negative 1, that's a vertical asymptote. If I put in 4, that's also a vertical asymptote. And then I'm also going to plug in where these two functions are equal. So x plus 4 over x plus 1 equals x minus 2 over x minus 4. If I cross multiply, I have a difference of squares here, so that's x squared minus 16 equals x squared minus 2x plus 1x is minus x minus 2. See the x squareds go away. Add 16, I get 14. Add x, I get x, yeah. So I get 14 way out here. So then I just do a simple math, a little bit of math here to find out which one's on top in this interval, because this is the only time that they're equal, and these are the only other two times that they're going to switch from being on top to going to the bottom. So let's plug in negative 2 here. Let's try negative 2. So negative 2 plus 4 is 2, and negative 2 plus 1 is negative 1. The question is that less than or equal to negative 2 is negative 4, and negative 2 is negative 6. So that's negative 2, is that less than 2 over 3? And the answer is yes. So that one's good to go. So let's plug in 0. So if we plug in 0, we get 4. Is that less than let's put a little question mark here so we know what we're talking about. So is that less than or equal to plug in 0, which is a half? And that's the answer is no, so that's a no. And then let's plug in 5. So that's 9 over 6. Is that less than or equal to, plug in 5, we get 3. Plug in 5, we get 1. So what is that? 3 over 2 less than 3, and that's a yes. And then this has to be a no because they switch when they're 14 and there's no asymptote, so that's a no. So the answer is from negative infinity is less than x is less than negative 1, and when 4 is less than x is less than or equal to 14. They're equal there, and I want to know when they're equal. And there's our answer.